Okay? What I'm trying to do today is give you some general background from the beginning of today's lecture until week 12. So we will cover many of the cognitive aspects, so how we can use this human cognition in information design. So today is kind of summary of the whole 12 weeks lecture. So we will step by step to investigate or examine each of the topics. So today is very important to summarize whole of the lecture, right? So many times and many years in cognitive psychologists and human-computer interaction researchers study about how the human behave or process the information. So this one is pretty much a simplistic model of human mind. So this one is exactly mapping with our course structure. And our textbook is exactly following these steps. Okay, basically, okay, we human beings receive the information. Okay, we receive the information through your eyes or through your audio, the ears, or sometimes tactile feedback, tactic feedback. So this information stay very short time, really short time, onto sensory memory. Okay, so your eye has your visual sensory memory, your audio, your ears has a very short time interval, the short time interval memory for your audio information. Very short time. Stay very short. So without any intention, all the sensory information is gone. Okay? Only you can pass from this information into in here. Okay, is you need attention. When you pay attention, you can move the information from sensory memory into working memory. Point is, attention is limited. Sensory memory, all we know that sensory memory, there is no limitation. We can receive as much as information as you can. However, attention is limited. That's why we cannot pass all the information from sensory memory into working memory. Okay, so, that is one limitation you have to bear in mind. And the second one is when you pay attention to, all the information can go into the working memory, right? So, but another limitation in human resources, working memory is also limited. Okay, I will explain how much we can hold some information in working memory type. So, when you have some encoding and decoding process, you can communicate between working memory in your brain and long-term memory. Right. So that is a simplistic approach in our human mind. So how we process the information. So the chapter 4, 5 is covering this one. Chapter 6 to 11 is covering to this working to long-term memory in our textbook. Good. So as you see yesterday is the most important, the first part of the human information processing is this sensory input, right? I will, quickly go into the working memory. So this one is you have seen. So the point is when you want to raise an issue is when you see is what is out there. So that is one of the example. So the visual sensory memory is receive the information. However, intentionally we process this visual information or visual structure in a different ways. That's what we are different with the computer. Computer cannot access certain visual structure to identify the product, or recognize a product or matters or object. However, we human being can do this process. Okay, this one is you seen yesterday. Okay, that's why visual structure we can easily recognize this type of information. In particular these cases, but this one is we have some difficulty to recognize which one is which. Okay, this one we have done yesterday, and this one visual perception is also, if you have some kind of color coding, we can have some benefit to understand more quickly recognize a certain information. Okay, that's one you see yesterday. Okay, this one is visual perception of speed. Okay. So this one is we haven't accessed yesterday because we have some kind of network issue. But if you go to my personal homepage, so anyway, you go to my webpage and there's many testing. Visual search testing, memory testing, working memory testing. You can play around with my application. Okay? Okay, this one is Gestalt psychology. So that Gestalt psychologist is working toward identify the visual structure. So there are four, mainly they suggest 8 different types of visual structure, but these 3 of them is most popular visual structure. So as I said yesterday, this one is people can, ooh. People can have some kind of continuation. Okay? Okay, oh, it's fun. Very good. Okay? So many of the Gestalt psychologist outcome is being used for interface design. As you can see, the grouping can be done with this line, or these 4 different lines can give you a feeling about the tab in interface. Okay, so you've seen the auditory perception is also different perspective in human being. Okay, so this one is that. Okay, from now on, so today's lecture is more focusing on the rest of the information processing from the attention to end of the long-term memory. So you know the captcha code, right? When you register your email, make your personal email account, you have to type in this captcha code, right? To avoid what? Why we need captcha code? And sometimes the web bot is going into any of the web accounts, so they can generate as many as email accounts for the web bot. So to avoid these kinds of issue, only human being, computer cannot recognize this code, right? Human being can do it. How come? That is your first quiz. So, software program known as captcha code are used in research and practical application in this field of the perception. So what is being used? Color, movement, distance, or patterns. So I can give 30 seconds. Okay. Yes. Around 92% of correction. Okay, so answer is D. Okay, so a couple of students was wrong. Okay, but many of you. So as you can see, this one is very powerful application to use pattern recognition. Can human being do it? But computer cannot do that. So this kinds of technique is being used in many application design. So using, of course, is cognitive aspect. Okay, thank you. So we can move into the next slide. So that is part of the sensory memory we roughly discussed, right? So from next week, we're talking about this one in more detail, including many other examples. The next major topic we will handle with week 4 and 5 is attention. Okay? Attention is very interesting field. Okay. What is this? What's that? Urinal. Okay? Urinal. So can you see this letter? What? Small letter in here. It says proper urinal etiquette. So every design has a reason, right? So why we have this small letter? A female may not know it, but I mean the male students like you. Why we have very small letter in here? Why we cannot have a bigger one? We cannot see easily, right? Why? It's technically. Okay. Why? Pay attention. Okay? So that's why we put very small letter in here. So if you want to pay attention, you have to get closer to the urinal. Isn't it? That's the why. Even though that is you can make a bigger letters, but intentionally this designer used a very small letter to make you pay attention. Likewise, attention is limited. Okay, you can't play around as many as information, right? Because we have a limited number of process in our brain. What is problem of this situation? How many things she's doing now? How many jobs? 7? Who says 7? I think 3. Okay. Making up, phone call, and driving at the same time. Can you do that? In our perspective, we can do it, but has a problems. So when you have expertise, okay, many times more experience can make you perfect. She can do everything she wants, but in general situation, human being cannot do many things at one time. So the question is, how many things we can do? So that is important issue in every information design, okay? So when you do information design, okay, mobile phone, computer application, designer can provide as much as information to the user. You can do it. The heaps of information on display. Now it's a 26 LED display, resolution is a 2056 by something, bigger one. So you can provide as many as information you can. A problem is people might not know it, might not recognize it, because we have limited number of attention resources. Say, okay, we can't do many things, pay attention at one time. So limited or unlimited. Many of the experimental research outcomes say we have very limited number of resources on attention. Okay? Another problem in attention is we can't move between the information as quickly as possible. It takes time to focus on one thing into the next thing. So for example, if I'm looking at him, and then if I'm looking another person, it takes time. Ages sometimes. We can't switch between the information very quickly. We can't. So example is in here. This one is not American Funniest Video.
This video shows a participant from a 1998 study by Daniel Simons and Daniel Levin. Watch what happens as the unsuspecting pedestrian provides directions. The young man on the left is one of the experimenters. He has approached the white-haired man and asked for directions. Watch closely as two people carrying a door pass between them, and the first experimenter is replaced by someone else.
Okay.
Many of the people in the study, the pedestrian was entirely unaware that he was talking to a different person.
So the question is why this old person, old man, cannot recognize the people were shocked. People change it. The reason? Takes time? Why? Chang-san, what do you think? Why this old man cannot recognize?
Just focus on the map.
Yes. He only pay attention to on the map, nothing on face recognition. So if you pay attention to, perhaps if this pedestrian is female, it could be different. Okay, but the old man doesn't care about he much, so the only thing on the map. So he only focuses on the map. So our attention, this old man's attention, goes into the map. So he cannot recognize the people has been changed. Okay? So likewise, all our attention is pretty much limited. Okay. That's why I want to show them. Okay, this one is another thing, so another attention issue. We saw the visual attention limitation. This one is more central limitation in human cognition. So many people already know that we can't use mobile phone while we're driving, right? So many countries prohibit this kind of driving exercise. It's illegal. Okay, you have infringement, fines, right? Why? Because they want to make money from this one? For the policemen's salaries? So why? Why this one is not useful, or is why this one is dangerous thing, dangerous practices? So, of course, is many car simulation is identified while we're driving. While you're driving, the mobile phone use make you some more deteriorate your driving performance. Okay, but a more intrinsic approach to understand the careless driving while you're using mobile phone is done by Cohen and Graham in 2003 experiment. What they did is they questioned about if we compare between mobile phone use versus just in-car conversation. Okay? So that while you're driving, your passenger and you drivers can talk to each other, right? But at that time, it isn't much trouble, isn't it? You can drive and talking with your passengers, right? But why the mobile phone is dangerous? It's the same conversation, same talking. So why? So do you have to prohibit all the conversation while you're driving? No talk, never, ever. So that's their question. And then their idea is conversation, if you want to converse with someone else, you have to pay attention. Okay? Right? If I want to talk with Jang-sun, I have to look at him, and then we all established common ground. And then we can make a conversation. Okay? But on the phone conversation, mobile phone conversation is that the other person never know what situation I am in. Okay, and the passenger knows it because she or he is just next by me, so they know what I'm doing. Okay? But mobile phone users, the other person in over the mobile phone, they never know what situation you are in. That's why they identified common ground issue is major problem in driving and mobile phone use in the driving, and they identified, okay, conversation need many attention, okay, central cognition, and this one can be interpreted by common ground theory by Clark in 1982. So that's why mobile phone is dangerous. Limitation in our attention level, attention resources. Okay? That's why many of the new products, new in-car navigation system or dashboard is changing like this way. Okay, when you're driving, you need a map. So the BMW proposed a new interface like this one. They display the information in window. Of course, it is expensive. That's BMW. Okay, but one day, if you to avoid any kinds of, this product design or information design can help to address some human limitation, in particular attention level. Okay, so next one. Another one is limited resources, right? So that is our main topic of discussion, and we're trying to do a couple of experiments, right? With you guys right now. So you have to find T. Okay? Finding T. It is easy, right? To find the T. So I will double the information. So we have only 9 information in here, right? I will make 18s. So whether you feel this one is still difficult or still easy or difficult against this one. What do you think? More difficult or just the same as with the previous slide? Similar? Okay. I have to find the blue L. Okay. We have only 8 information in here. Okay, not much difficult as I said. I will double the information. Same as? Similar? Okay. Now it's vertical T. Okay, we can find easily in here, right? When we double the information, the same way, but it could be, now it's vertical T. We have 9 information. This one, what do you think? It take more time? Huh? Vertical T. We have in here. Right? So compare with the previous one. Okay, this one is quite easy to identify the vertical T, but when you have same number of 9 information, it takes more time. Why? So why that happens? So as I said, attention is limited, right? Attention is limited. If you want to find the T, vertical T, it takes more time because they have to pay attention to 2 or 3 different information. Sternberg paradigm. Yesterday I mentioned this Sternberg paradigm. When you have more information to filter out or check with the original information, it takes more time, right? So likewise, when you have 9 information, but if you want to find the vertical T, you have to filter out R and as well as slanted T. If I double this information to make 18, it could be worse or better? Worse, yep. It's 18 information, am I right? 18 information, vertical T is in here, but it takes much longer to find it. Color coding is same wise, okay? Blue L is very difficult to find it in here when you have, yes, most of you will give up to find the blue L. So likewise, as I said in the previous slide, is attention is pretty much limited. So when you develop information or product, you have to be very careful whether your design or whether your information can be processed by the limited human resources. Otherwise, okay, this one is Sternberg paradigm, similar with the Sternberg paradigm. Otherwise, very big disaster, the critical disaster will happen. Some of the implication to use, this one is, this example is from the critical safety systems such as nuclear power plant, cockpit design, aeroplane, cockpit, and the chemical industry. So there's heaps of gauges. So operators is playing around this size of room. Okay, we have heaps of display, which means a lot of information to the operator. So operator make a decision based on this gauge information. So if their task is to looking at only dial, they can easily find abnormal situation, isn't it? So if their task is looking at the light, so of course it is easy because they can only pay attention to one information, which means light. This one is kind of gauge needle. If we combine these two, likewise in this picture, it takes time. Okay, because we have to look at the light as well as abnormal situation at the same time with the needle reading, so it takes more time. If this design happens, we have a significant or critical disaster like 3 Mile Island in New York, New Jersey. The same problem, similar problem with this one. The nuclear power plant is almost, problem like what we had Tokushima in this year. The 3 Mile Island has a similar display like this one, so operator cannot identify the real problem with this information. That's why we cannot make a busy display like this one, because we can't process such a many information at one time. That's why we have very small number of icons on your mobile display, or in computer application, even with a large screen, you can have very small number of icons or menu items. How many menu items on Microsoft Office? How many? See? So that is menu item. Okay, all of them 7. Even though we have a big screen like this one, we cannot make more than 7 or 8 menu items. The reason is we can't pay attention to at a time. Okay, every design has a reason. Okay, that's what I want to say. Another one is this one. This one is attention failure problem. So if you're looking at the Google search, if you do some Google search, you can find many interesting examples when the attention failed. This one is one of the example. Flight 41 in Florida, I guess. Hang on, I will check it. Here we go. 1972, Florida Everglades Airport. The East Airline 41. We say, we don't have this one. So East Airline 41, and the aircraft carrier number is L1011. So if you search with that, you can find a very interesting example in something about attention failure. The situation is very simple. We had 3 pilots, okay, in 1972 in this flight, and when they tried to land on the airport, there is one button turned on, one lamp. Okay, one lamp turned on. It was the landing gear problem. It was landing gear problem. So 3 of them, okay, discussed, say how they can land safely to avoid, it's crash, right? Of course it is. So there's a lamp turned on, and 3 persons decided they want to put this flight into automatic mode. Okay? At the same time, these 3 people are looking into find the problems. Perfect, right? Automatic mode, they're trying to search the problem, right? But suddenly, one of the person, never know who did, touched the yoke, 조종관, okay? When they touched the 조종관, yoke. The yoke, say, this flight goes into manual mode. But that wasn't displayed on cockpit or any gauges, no lamp. 3 people believe that they're still in automatic mode, flight mode, but actually that is manual mode, which means nobody controlled the flight. What happened? Crashed it. 236 people, some amount of people were dead. Because of the simple light problem. Of course, that is attention problem, because this yoke or this whole interface design didn't provide the right information at the right time within the limit of human resources, because they all pay attention to indifferent things. Okay, 3 people all together, only computer knows they are not automatic mode. Since then, their practice, code of practice is been changed. When they have 3 pilots, only 2 people find the problem. 1 people have to hold on yoke in any time. Okay, so likewise, job practice or task procedure is also related to our attention limited attention. Okay, the next one is more interesting, should be. Okay, this one is part of things, so we can cover this one up to chapter 4. And from the chapter 5, we will discuss about working memory. It can have a RAM like 8 gigabyte or 16 gigabyte memory, right? But cache memory is limited, isn't it? Very small, because expensive. They are very expensive, but they are really fast. Exactly same thing in our human brain. In human brain, working memory is very small capacity, but long-term memory is huge, unlimited almost. So you have to handle this working memory very carefully. Say, okay, the main function of working memory is processing the information from visual or sensory memory through the attention. Okay? Okay. Capacity is very important. 7 plus minus 2. Probably your HCI course is, you heard about this Miller 7 plus minus 2, right? Magic number 7. How many colors in the rainbow?
7.
Is it real 7? Physically? More than 7, isn't it? What about musical scale? 7. Telephone number? Get rid of the carrier network number, 010, get rid of it. The rest of it, 8, isn't it? Car registration number, the plate number. Korea, how many? 7? America? Brazil, how many? 4. Really? Okay. So 7. America, something 8. Japan is 9. 6 to 9. It implies a human being evolved like that. Okay, human being evolved to happy about this number 7. That's why we call the magic number 7. Other example, hips. We saw that, it's a Windows system. The top menu is 7. Top menu item is 7 or 8. Most of them. Interesting, isn't it? So we found this one later on. And then duration is a little bit longer, 30 seconds. The sensory memory is a millisecond the time, or 0.3 seconds or 0.7 seconds, but working memory has a little bit more time. And this working memory can be extended when you do some practice. So when you see the stacking, okay, the program, the Saturday program stacking, some people has a really brilliant talent to memorize all the numbers, right? They are not special people. They are trained. They extend their working memory significantly with some tools, such called rehearsal. When you do the rehearsal, of course, as you do when you prepare your final exam, okay, you have to rehearse many of the context, many of the text, right? So memorize it. So if you have this kind of practice, sometimes this one can be extended over this limit, sometimes. But when you need normal situation, it come back to 7 plus minus 2. That is happen. Okay, 30 seconds is important thing. Okay, And this one is really important issue, so that it will cover whole week to explain what is the meaning of dual code in working memory. So my supervisor, so he developed this idea. Okay, Badley is, he made a working memory, the name of working memory, and he identified also we have dual code, such as the working memory has two separate dimensions. One is visual working memory, the other one is audio working memory. Let me ask one question. So when you prepare your final exam or any of the tests, you listen to the music while you're studying? How many people are doing it? Okay, you're playing, okay, listen to the music and the studying, right? How can you do that? People have limited resources, right? But point is, this working memory, visual working memory for your studying, and audio working memory is different, so that we can do it. Huh? But if this one is only one, combined one, of course your test performance is really poor. Right? Because this one limited, so the half of them is being used for you listen to the music, half of them is reading text, so it is not better performance. But these two is separate things, so this one and this one can be work in separate way. That is what Badley identified, but more recent data or experiment data, it doesn't support this idea. It might be one thing. It might be one thing. But nobody knows yet exactly, but anyway, what Badley proposed is we have dual code. One part for audio working memory, the other one is visual working memory. Okay? Problem of elderly people? What do you think? Elderly people? So, is elderly people has a problem of this part? Okay, let's go back. I will show example. What do you think? Elderly people has a problem in working memory or long-term memory? Which one? So as you know, elderly people has dementia, right? Dementia, the memory loss when you get older. In Korean, 치매, right? So how come? How come they happen when you're getting older? This part or this part? Huh? Both? Major problem of elderly people is this one. Major part of their memory loss comes from this one. So this one make effect on no encoding of new information into long-term memory. Of course, elderly people has a difficulty to retrieve it. But major barrier for the elderly people is working memory is reduced or diminished. Okay? So if you want to make some product or website, or some product or items or anything or service, this part must be considered. So you human being, you guys is the younger people has a pretty good number of working memory type, but elderly people, perhaps half of them, half of us. So that's why you have to make web interface with a bigger font size for their visual information, much easier. And then number of item must be reduced, not 7 or 9. Okay, iPhone for the elderly people, imagine it. 12 menu icons? Maybe 3 or 4. So if you're looking at the Google search at the elderly phone, okay, we can do it. Mobile phone. So in this picture, okay, they have a bigger, right? Bigger number, well, bigger font. And that's not what I want to show. See? So this one is somewhat different product for only elder people use it. So their working memory is pretty much limited. So only they have designated some number, phone number, and something like that. Okay, let's go. Okay, so I mentioned this part. So working memory is pretty much limited. Dual code is important concept. So this one is some test with you guys. There are 7 plus minus 2. So I will show this some of the letters. So you can see only 5 seconds and remember as many as letters. Five letters. 6, 3, 3, 4, 5, 0. Okay, sounds like 0. Nobody raise your hands. Okay, how many words? How many letters have you remembered? 3, 4, 5, 6. Who had the 9? Oh, speak out. Is it? Oh, very good. So she has a really good working memory. Okay, some of them, I mean, that is it's not controlled experiment. But many times when I do this experiment, around 4 or 5 is the maximum number of to remember in 5 seconds. But my question is, if I change the line letters with the contextual meaning, okay, the 9 letters exactly the same with the previous slide, but it is much easier to remember, right? Because that is how we can use the context, word context. That called chunking. Some people who have a really good working memory, or we just say, oh, they are talented people to memorize something, is they have expertise to make a chunking of information. Such as some of the technique we're being used in the memory improvement, okay, like this one. If you have 100 different information to have to memorize, some people using a spatial information, such as this information goes into room 1. They imagine it, okay? So this whole information goes into room 1. This one goes into second floor, room 5. So they are put the older information in different place, but they remember only spatial information, the map. So if I ask you, what information 1 is, they are retrieving this one from, okay, this spatial information like apartment, okay, level 1, room 1. So that's why they can have a better memorizing skill using chunking. Or that is spatial chunking. This one is word chunking. Okay? Some people, when you have many information, they are trying to make a word or a sentence. Okay, probably you're in the secondary school, you have many experience to remember whole the science or history exam. You're trying to make a small sentence, right? So such as in Korean, is 태정 태세 문단세, right? That is kind of chunking. You don't need to remember whole the 26th Joseon Dynasty king's name. Only they can use the first letter to make a chunk. That is how we can improve working memory, the capacity. But that is short-term effect. It doesn't have any long-term effect yet. That's why even though we're helping the elderly people to boost up their working memory level, it is not much working psychologically. Temporarily working, but long-term is not much benefit. That's why we have to use the medical treatment at the same time with the cognitive treatment. That's why I'm working with the medical school. So I'm teaching these medical people to using my cognitive skill, and they are doing, of course, their medical treatment for the dementia people. Okay, so implication is very important from this working memory limitation. So one of the major issue in information design from cognitive psychology is consistency. Okay? What is consistency? Groupware. Okay? So if you look at the MS Word, MS PowerPoint, MS Excel, it's similar, isn't it? The menu icon, menu items, icons are pretty much similar. That's why we can use this groupware much easier. When you learn one thing, for example, MS Word, that idea or that experience can go into the second application, such as PowerPoint. So when you develop consistent interface or consistent information, people can use the interface very easily, because one lesson can transfer into the different working situation. That's the beauty about Apple. Apple has not been much changed since 1967. Of course, its outlooking is pretty much different, but main core is not much different. Same desktop, okay? Desktop layout, and from the beginning to the up until now, they have a similar interface. Microsoft has a similar interface too, but it's a slightly different philosophical design philosophy, so that is a little bit difficulty in version differences. And training wheel. Okay, this one. Another example Apple is iPod, iPad, iPhone is all similar interface, right? Okay, another idea about training wheel is, okay, perhaps I can find some example. So when you have these items, information in here, sometimes there are arrows in here, right? In here, which means you can do more options. You can find more options, right? The idea about this design is the beginner, the novice user, doesn't need much function, doesn't need many functions, right? Only they need is basic functions. But when you get used to it, you need more functions, right? So that's why the top one is more convenient one, more common or more popular, more frequent use items must be put in the top menu. And if you need more options, okay, for the expert, likewise, okay? So training wheel is the concept for developing some interface for, okay? As you can see from this arrow button, you can find the bigger one, the more options, that is example of training wheel. Okay, so this one is another training wheel example, and this one is chunking example. So they can make a two layer, one is in here and the other one in here. So using this kind of two different chunking system, we can avoid the working load overload. Okay, limited attention, limited working memory space. Okay, last one is this part, long-term memory. Okay, but problem is our textbook is covering 3 chapters for long-term memory and linked to decision theory. Okay, decision theory means, how we can represent the information and how the information is stored in the long-term memory. Visual information, or spatial information, or auditory information, or declarative knowledge, how these things are represented in long-term memory is the major research topic. However, we don't have any clear evidence yet. Still working on. So our textbook covers 3 sections, including the decision problem or problem-solving situation with the last 2 chapters. The long-term memory is organized and store the information, okay, unlimited capacity. And duration is thought to be permanent, but it needs to be rehearsal. So you have to rephrase it many times. And then you can stay many information. Okay. And this one, okay, link to the knowledge representation, like a declarative knowledge, which we cover in chapter 11, and procedural knowledge. Okay. So this one is pretty much linked to the computer science. So computer science cannot cover this part. Only they can do is this part with AI logic, artificial intelligence logic. So how the knowledge is represented, how the information can be retrieved when the situation happens with a certain AI logic, such as neural network, artificial intelligence, what is that? The Bayesian network, such things is being used. So this one is desktop interface, right? Okay, this one is all the Unix or DOS operating system. Okay. Why this one is much easier to use? Any reasons? Why this one is difficult? Linked to this part. So in terms of long-term memory, what do you think? This one? Okay. The reason why this Unix system is you have to remember the command, right? Command syntax. And then it goes into your long-term memory, and then when you need to use it, you have to retrieve it. That is called, in technical terms, recall. Recall. Okay? But this desktop interface sometimes doesn't need recall. They need only recognition. Recognition of icon or recognition of label is enough to use this whole interface. So recognition. So this one is done by working memory. Recall is done by long-term memory. Which one is faster? Long-term memory or working memory? That's why this one is faster. Which means this one is better. Okay, desktop interface is better in terms of our speed, recognition speed. Okay, this one is take time. This one is less take time. But I'm not saying the desktop is the best. Okay, we have different interface now. Apple iPhone or Galaxy is double finger, or sometimes my MacBook has a 4-fingered interface. Okay, so you have to develop new interaction style to avoid the limitation of the recognition. Of course, this one is not the perfect. That's why in one day, if you're developing the new product, you can apply the knowledge of cognitive psychology in your product or information design. That's what I'm suggesting. That's why I'm the main objective of this course. As I said in the beginning lecture, starting lecture, is I'm not teaching the cognitive psychology just for my specialty. I'm teaching you psychology when you need to design product, service, information. You can apply cognitive psychology or cognitive aspect of a human being. Like when we see elderly people, younger people, disabled people, female, male. Okay, when you design something, the design has reasons. Okay, so that reason mostly comes from this cognitive understanding. Okay. Oh, this one is a good example, isn't it? So this one is really useful. The reason is, basically, if you want to make a chart on Excel, initially, in a long time ago, we have to memorize the step. Step 1, step 2, step 3, step 4. That's why you have to learn from the textbook. Okay? The book. You have to buy it to use the Excel. Nowadays, we don't need such a book much, right? We don't need. We just try and use, right? Trial and errors. The reason why we do that is interface designer or application designer supporting us, such as this chart example. Say, if you want to make a chart, activate chart widget, and then following the step by step. Select, and then go to the step 1. We choose one of them, okay, and then go to the next. Okay, simple. Click next, right? So that is the beauty about knowledge representation. If you designer to make this kind of chart widget, you have to represent human knowledge or users' knowledge. How they doing it. You survey it, you interview them, so to identify what procedures they are taking. When you understand their step 1 is choose the chart type. Step 2 is decide the space or something or chart. Step 3 is something. So when you identify these different task procedure from user survey or user interview, you can make this chart widget thing. That is we called user-centered design. Okay? This user-centered design comes from this understanding. So when you represent the knowledge, we can retrieve from the users and then apply this understanding for your system design. Get it? Okay.